Hello friends, today we are going to see a problem on DFT using matrix method. So we'll be using matrix method to solve a DFT problem. Now, what is the benefit of using this method? This method is used to solve the problem faster as compared to formula. We will be using formula, but we will be using multiplication using matrix. So that really speeds up the process. This really helps in lengthier problem. So you can solve the lengthier problem easily using this method. So what is this matrix method? Now, let us say that my definition of DFT is x of k, which is equal to summation n is equal to 0 to n minus 1 x of n e raised to minus j omega n, or I should write 2 pi k by n instead of omega. Okay, so instead of omega I will write 2 pi k by n. So that is the definition of my DFT. So I'll write it again. It gives n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi n k by n, where my k is ranging from 0 to n minus 1. Right? Now, suppose let us take for example capital N is equal to 4. So this is also called as 4-point DFT. So in general, any problem in DFT is called as n-point DFT. Now, for a 4-point DFT, if I will express this form, it will look like n going from 0 to n minus 1, which is 3, x of n e raised to minus j 2 pi n k by 4. Right? So if I cancel this 2 with this 4, I am going to get summation n is equal to 0 to 3 x of n e raised to minus j pi n k by 2, because I have divided this 2 with this 4. So I got pi by 2. Now next, let us substitute the values of n. So when I substitute the value of n, I will get x of 0 e raised to 0 plus x of 1 e raised to minus j 2 pi. We have nk, the n value is 1, so I get k by 4. Okay, you can either write pi k by 4 or you can write pi k by 2 if I cancel this by 2. Okay, so either I'll get pi by 2 or 2 pi by 4, no issues, plus x of 2 e raised to minus j 2 pi, now n value is 2, then k by 4, that is when n is equal to 2, plus x of 3 e raised to minus j 2 pi 3k by 4. So what we have done is, in that formula I have substituted the values of small n and we have elaborated this series. Now if I rewrite it properly, I am going to get x of 0. What is e raised to 0? It is 1. Right? Then plus x of 1 e raised to minus j 2 pi k by 4. So I can write it as e raised to minus j pi k by 2 plus x of 2 e raised to minus j, this is 4 by 4, so it becomes pi k plus x of 3 e raised to minus j, this becomes 6 pi by 4, which is 3 pi by 2. Right. So now this is my x of k. This equation now is a function of k alone. Now I will go on putting the value of k. So when I put k is equal to 0, I'll get x of 0, which is x of 0 into 1 plus x of 1 e raised to this I'll put as 0, so it becomes e raised to 0 plus x of 2 e raised to 0 again plus x of 3 e raised to 0 again. This is because I have put it k is equal to 0. So I will get capital X of 0 equals to small x of 0 plus x of 1 plus x of 2 plus x of 3, because all e's we have as 1. Then I put x of 1. I will get x of 0. Now it will not affect over here because n is 0. So whatever the value of k is, this factor is always going to be 1 plus x of 1 e raised to, now I'm going to put k as 1 over here. So I'm going to get minus j, okay, 2 will use this. It will give me, okay, let us use this 2 pi into 1 by 4, which is ultimately result into pi by 2 alone, plus x of 2, let me use this, e raised to minus j pi, because here k is equal to 1, plus x of 3 e raised to minus j 3 pi by 2, because here also k is equal to 1. Similar fashion, if I put x of 2, here the value of k is 2, so I write x of 0, first term doesn't matter, it multiplies by 1, then x of 1 e raised to minus j, let us use this, pi by 2 into 2 will give me pi, right, because I'm putting k value as 2. So if k is 2, 2 and 2 will get cancelled and I get e raised to minus j pi, plus x of 2 e raised to minus j, let us use this, minus j pi into 2, so that will give me 2 pi, okay, plus x of 3 e raised to, here if I put 2 now, it becomes 6 pi by 2, okay, 6 pi by 2 can also be written as 3 pi, okay, so I'll get minus j 3 pi. Again I repeat, when I put x is equal, k is equal to 2 over here, 2 into 3 will give me 6, 6 by 2 will give me 3 back, or this 2 and this 2 will get cancelled and I get 3 back, so it is 3 pi. Then lastly we'll put x of 3, which is x of 0 into 1 plus x of 1 e raised to, let us come back here, minus j pi by 2 into 3, so it will give me 3 pi by 2 plus x of 2 e raised to minus j. Now here let us put k is equal to 3, so I'll get 3 pi plus x of 3 e raised to minus j. Now when I put 3 here, it is becoming 9 pi by 2, so it is 9 pi by 2, okay. So what you see is, as I am going on changing the value of k, so I'm changing the value of k in this fashion, k is equal to 0, 1, 2, 3, I am developing a new row. So this is a complete row. So I am developing a complete new row in which x of 0, x of 0, x of 0 is the first column element, x of 1 is the second column element, x of 2 is the third column element, and x of 3 is the fourth column element, with a multiplying factor of e raised to, let us say, e raised to minus j 2 pi n k. We will have x of written as x of 0, x of 1, x of 2 and x of 3 over here, which I write it as a column, and I have a second column which I write as x of 0, x of 1, x of 2 and x of 3. Right. So this column is having 4 rows and it's having 1 column. Similar way, I have here 4 rows and 1 column. Now I have something to multiply with x of x of n, such that they will produce x of 0. So I have a matrix which is a 4 cross 4 matrix, because the inner dimension of the matrix should match. For that reason, we have to keep a 4 cross 4 matrix. Now this matrix is called as twiddle matrix. So a new term has come in picture which we call as a twiddle matrix. Now let us see what is this twiddle matrix set and how to develop it. So in the definition of DFT, we have x of k, which is equal to summation n going from 0 to n minus 1, x of n e raised to minus j 2 pi n k. Right. So I say twiddle factor as this, we called it as a twiddle factor. Now the twiddle factor definition is given as Wn raised to 1 is equal to e raised to minus j 2 pi by n. So here the factor is into 1. So when we write Wn raised to 1, it is equal to e raised to minus j 2 pi by n. The index of w is positive, whereas the index of j is negative in exponential term. So if I replace it, it becomes x of k, which is equal to summation n going from 0 to n minus 1, x of n w n raised to, now instead of 1 I have here nk, so I will write nk. So this factor is called as a twiddle factor. Okay, now instead of every time calculating the twiddle factor, let us see a simpler way. We know that we are in an omega domain or a Fourier domain, which is discretized or which is sliced up into some points. Now let's say that in our previous example our n is equal to 4. So I'm going to chop up this circle into 4 equal parts. So my chopping will be 1 point over here, 1 point let's say over here, 1 point let's say over here, and 1 point let's say over here. The value over here is 1, value over here is minus 1. Value at this point is j, value at this point is minus j. Okay, now this factor or this value we called as w4 raised to 0, which is nothing but equals to 1. Then we have this factor as w4 raised to 1. Then this factor is given as w4 raised to 2, and this is w4 raised to 3. So I have 4 components: w4 raised to 0, which is equal to 1, w4 raised to 1, which is equal to minus j, w4 raised to 2 equals to minus 1, and w4 raised to 3 equals to j. Now I will develop that matrix. Now the matrix, every matrix has a number of rows and number of columns, right? So this will be our 4 cross 4 matrix. That means there will be total 16 elements. So the first element is w4 raised to 0, because here the value of k will be 0. If the value of k is equal to 0, the whole row will have the index as 0. So this will be w4 raised to 0, this will also be w4 raised to 0, and this will be w4 raised to 0. Then I will shift to next value, that is the k is equal to 1, and I am going to get a new row. But in that row I have n factor also changing. So when I put the value of n, it will affect in this direction. So for the first column the n value is 0. For the second column n value is 1. For the third column, the n value is 2, and the fourth column, the n value is 3. So I will get here everywhere the n is 0. I have the factor with Wn raised to nk. If k goes 0, then also this product will turn to 0. If n goes 0, then also this product will turn to 0. So now I will have W4 raised to 0, W4 raised to 0, and W4 raised to 0 over here. Okay. Then I will have here as W4 raised to, now k is also 1, n is also 1. So when n and k I put, I get 1. Then I have W4 raised to, n is, okay, let us say this as k is equal to 2, this is the row, and k is equal to 3, this will be the row. So here k is 2 and n is 1, so you get 2. Here k is 3 and n is 1, so you get 3. Now k is 1, n is 2, you get 2, and here it will be 3. Here it will be 2 2s are 4, and here it will be 6 because 2 3s are 6. Here it will be again 6, and here it will be 3 3s are 9. Now you would ask a question that, okay sir, previously we have seen that there are only 4 values, W4 raised to 0, 1, 2 and 3. How to get the values as W4 raised to 4 and W4 raised to 6 and W4 raised to 9? And the logic is very simple. As we are moving on a circle, so this is my circle, and I have 4 points on the circle. I call this as W4 raised to 0, this we call as W4 raised to 1, this we call as W4 raised to 2, and this we call as W4 raised to 3, right? Now, when I go from here, I get 0, 1, 2, 3, then we have 4, which is this point again, then 5, this point again, then 6, this point again, then 7, 8, 9, 10, 11, and n number of points I can calculate in this way. Okay, so as I'm moving on circle, after 3, the fourth value is the 0th value again. Okay, so based on this, let us find what is this 4 cross 4 matrix look like. Now W4 raised to 0 is equal to 1, W4 raised to 2 is minus 1, this is minus j, and this is j. So we have W4 raised to 0, so there will be all 1s, here will be also all 1s. Then here it is W4 raised to 1, which is minus j, then W4 raised to 2, which is minus 1, W4 raised to 3, which is j. Then we have W4 raised to 2, which is minus 1, then we have W4 raised to 4, which is 3, and then 4, which is 1, W4 raised to 6, which is 4, 5, 6, minus 1. Then W4 raised to 3 is j, W4 raised to 6, so this is 4, 5, 6, which is 6. W4 raised to 9, now 6, 7, 8, 9, which is minus j. Okay, so the matrix says 1, 1, first row, first column, all ones, minus j, principal diagonal, j, j, opposite to principal diagonal, minus 1s in a rhombic shape, and 1 at the center. So this is a twiddle matrix for a 4-point DFT. Now, just for an example, because I asked that let us solve a problem, so let us take x of n as 1, 2, 3, 4. So if I take an example of 1, 2, 3, 4, then my x of k will be equal to a twiddle matrix into my x of n, which is 1, 2, 3, 4. And now I know, because it's a 4 cross 4 matrix, because my n is given as 4, so my twiddle matrix will be 1, 1, 1, 1, 1, 1, 1, minus j, 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 minus 1, minus 1, minus 1, minus 1, 1. Okay, so here we have developed this matrix, and we have this 4 cross 1 a column matrix. So because the inner dimension matches, Of course, we can go for the matrix multiplication. Now in this matrix multiplication, we always know that the column will be multiplied by the row. So I have a column multiplied by row. I'll get 1 plus 2 plus 3 plus 4. It is 1 plus 2 plus 3 plus 4, which is equal to 10. Always remember, the first sample in DFT is always the multiplication of the samples in the x of n. Next, we will have 1 plus with this as minus 2j. So when I multiply 2 with minus j, it becomes minus 2j. Then I multiply 3 with minus 1, it is minus 3. 4 with j, it becomes plus 4j. So that is going to be, the real terms will be added together and the imaginary terms will be added together. The real terms addition will give me minus 2 and the imaginary term will again give me minus 2. So minus 2 plus 2j, because 4 is positive over here, so it will be plus 2j. Then for the third, I will have 1 minus 2 plus 3 minus 4. So that will give me 3 plus 1, 4, 4 minus 4 is 0, and this will be minus 2. And lastly, we will have 1 plus 2j, which this is plus, then it is minus 3, and then lastly minus 4j. So this will come as minus 2 minus 2j. So the final answer of x of k is 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So if I know this matrix, the calculations are very simple and it will give you results very faster as compared to solving the whole equation of definition. Thank you.